Okay, so now we're going to continue in Unit 1 on Chapter 3. We're going to continue on talking about radioactive isotopes. So let's say these two people make different pies. Susan makes an apple pie, and Dorothy makes a rhubarb pie. Let's look at how Susan's apple pie is consumed. So she cuts it into 8 pieces. After 15 minutes, half of the pie is gone, so 4 pieces remain. Another 15 minutes elapse, and only 2 pieces remain. Another 15 minutes elapse, and a little tiny sliver of pie remains. You know, everybody just keeps taking a bite. Pretty much it's gone. Now, the rhubarb pie, on the other hand, eight pieces, it takes 1 day for the pie to be halved. Another day elapses, and 2 pieces remain. Another day, and the little sliver remains. So overall, it took 15, 30, 45 minutes roughly for the apple pie that Susan made to disappear, whereas it took about 3 days for the rhubarb pie to disappear. So, which is the better pie? It appears that the apple pie is better, much more popular. It disappears at a faster rate, so the apple pie is better. So what is the amount of time required for half of the pies to disappear? So the half-life is another way for the apple pie. The amount of time it takes for half of the pie to disappear is 15 minutes. The amount of time, the half-life for rhubarb pie, is 1 day. So the rate of radioactive decay is a lot like how we just went through this story about the pies. So radioactive decay is expressed in half-lives. So just like pies, rates of decay vary from one isotope to another. So that brings us to definition of half-life. So it's abbreviated T1/2, and this is the amount of time required for a radioactive sample, the amount of time required for a radioactive sample to be halved. So half as much remains. So here is an example of a problem that we could ask you involving half-lives. Iodine-131 has a half-life of 8 days. If you start off with 1 gram of iodine-131, how much will be remaining in 24 days? Now with these problems, there are a lot of numbers. And there are a lot of numbers that don't matter. The main number you want to pay attention to is the starting quantity. So this is your starting. And the other number you want to pay attention to is the half-life. Okay, so the way we set these problems up, you'll put the starting quantity, 1 gram, and this is how much you start off at time equals 0. So if you set them up like the way I show you, hopefully you won't make many mistakes. But so you start off with 1 gram and a half-life elapses. A half-life is indicated by one of these arrows. Now for this isotope of iodine, the half-life is 8 days. So once a half-life has elapsed, the time is no longer 0, but it's at 8 days. Now the half-life is the amount of time required for the sample to be halved. So what is half of 1? Well, it's 0.5. Now this number here has 3 sig figs, so this one should have 3 sig figs as well, so 0.500 grams. Now the question asks us how much will be remaining in 24 days. So 24 days is what we want to get to. So we're not quite to 24 days, we have to keep going. So another half-life elapses, and the time is no longer 8 days, it's 8 plus 8, 16 days. And the amount of sample remaining is not 0.5 grams, but half of 0.5 grams, so it's 0.25. Now watch your sig figs, it should have 3 sig figs, so put a 0 after, so 0.25 grams. So we're not quite to 24 days yet, so we need to go through another half-life. So half of 0.25 gives you 0.125 grams, and the half. Now we've gone through 3 half-lives, so 8 plus another 8 gives you 24 days. So we have answered the question. The amount remaining after 24 days will be 0.125 grams. So you need to watch your sig figs, go based off the starting quantity. A lot of students get confused with the isotopes atomic mass. So when I was referring to a lot of numbers, iodine 131 does not matter. You don't need to pay attention to that. So if it helps, you can cross that off. What happens is a lot of students will put 131 and then they'll try and half that and keep going, and you don't want to do that. Also, mistakes that students have made in the past, instead of starting off at t equals 0, they'll think the starting time is 8 days, so they'll end up with 0.25 grams as the answer, and that's not correct either. So make sure that you set these up in a similar format. If you have a different way that you like to work them, that's fine. Just make sure it's consistent, and make sure that you start at time equals 0. So here's another question, another practice question for you. Technetium-99 has a half-life of 6 hours. If you start off with 32 milligrams of technetium-99, how much will be remaining after 24 hours? Now before we get into the details of this problem, I want to point out that you can have your starting quantities given in grams, milligrams, curies, millicuries, microcuries, all these different units. Just make sure that you report the unit, but it can be grams, it can be curies. Curies is a unit of radiation, becquerel, all these different units, but just make sure you express it in your answer. Now, as far as setting this up, technetium-99 has a half-life of 6 hours. If you start off with 32 milligram, that's your starting quantity. And the half-life, so we need to pay attention to starting quantity and the half-life. So in order to start this problem off, I'm going to write 32 milligrams. Time equals 0. I draw an arrow. That represents a half-life, and now my time is 6 hours. How much remains? Half of 32. So 16 milligrams, 2 sig figs. So we're not quite to 24 hours. We need to keep going. So I'll get another half-life, 8 milligrams remains, and that's 12 hours. Another half-life, 4 milligrams, and that's 18 hours. So we need to go through one more to get to our final answer, 2 milligrams. So there you go. Your answer is 2 milligrams. Now always check your significant figures. Our starting quantity had 2 sig figs, and our answer should have 2 sig figs. Make sure you report the right units as well. So on the next page, we have 3 practice problems. The first 2 are pretty straightforward like we've been doing. So the third one, you're going to have to work backwards. So I want you to hit pause and work these 3 problems. Okay, so with number 1, start off with 100 at time equals 0. You go through 1, 2, 3 half-lives to get your answer of 12.50 grams. Watch your sig figs on this one. On number 2, you go through 1, 2, 3, 4, 5 half-lives. And by the time you get to the 24.8 hours time, you can round or carry that extra digit around. Whichever you want is fine. But if you round or you carry the digit, you're going to get a slightly different answer at the end. And like we've talked about before, I won't take off points for that. I will accept both answers. So you could get 23.5 or 23.4 grams if you carried all your digits through. Just be sure in the end that you adjust your answer to the correct number of sig figs. So either answer I will accept, just adjust your answer to the correct number of sig figs. Now, in number 3, this was a different problem than you've been asked before. There are 5 grams of iodine 131 left after 40.35 days. How many grams were in the original sample if the half-life is 8.07 days? So just to start off, I don't care about what isotope it is. So they tell me that there are 5 grams left at the end. So at time equals 40.35 days. And so I need to figure out what the original was. So I need to go backwards. Instead of dividing by 2, I need to multiply it by 2. So I get to 10 grams. Time is going to be 32.28. So I'm not to 0 yet, so I need to multiply by 2 again. So I get 20 grams. Time equals 24.21. Multiply by 2, I get 40 grams. 16.14 days. I'm getting closer. I multiply again. 80 grams. T equals 8.07 days. Go back one more half-life. I'm at T equals 0. And my amount is 160 grams. And so I started off with 2 sig figs, and so I should end up with 2 sig figs in my answer. So that concludes Unit 1. Make sure you do all your homework problems, and make sure you pay attention to sig figs when you're working your homework problems. Practice, practice, practice. Work on the practice exam that was provided for you. Write all your questions down. Also, try to emulate a test-taking environment. So try to sit down for an hour and work on test-like questions. So don't look at your notes. Don't use your textbook. Just use your calculator, your pencil, and your brain. So, all right. That's all for Unit 1. Until next time.